Thank you. Right, without the servers.
Yeah, without the servers.
Okay.
We need servers.
Well, I'd like to talk to you about serverless. Serverless has been a growing trend in cloud computing, and its increasing popularity has been starting to match container systems like Docker. And for a good reason, because serverless promises all the features of the modern cloud for deploying robust and scalable applications, but without the hassle and maintenance of actually setting up and configuring server instances in the cloud. Now, have you been to SwiftConf last year? You might have caught Thomas's talk, so you might know a little bit about serverless now. Fortunately, there's a lot more to explore, so I hope you'll find some new interesting information here. And just in case, my slide deck has additional strategic placed pictures of animals throughout. So either way, I hope you'll enjoy this. Let's rewind back first to DubDub 2015, when Swift was announced to be open sourced and available on Linux. It was a huge deal, because finally the wall between our mobile application code and our backend server code was torn down. Previously, we couldn't really use any of our Objective-C code base on the server. And in terms of server code, it was either impossible or really tricky to run it on the device. And with Swift being cross-platform, this was finally a dream come true. And personally, and a lot of other devs, we're excited about the different opportunities that will bring and what kind of applications we can build leveraging this. Now, what I wasn't so excited about, and what dawned on me later, is where am I going to host this stuff? And how do I set up SSL encryption? How do I set up monitoring? I usually didn't do this stuff as an iOS developer. Who's going to maintain this setup? And as a developer, I always want to turn my focus into enriching my application rather than worrying whether my Linux server is still up at night. So this is where serverless and function as a service comes in. Now, you might have heard these two terms used sometimes interchangeably, so it's very important to know exactly what they are. Now, if I were to focus it down to the simplest possible definitions, serverless basically means that a service has no service to manage and that you pay for actual usage of that service. Whereas function as a service is a bit of a subset of that, because it focuses on executing your code, but instead of having to start your own server instance and execute your code there, there's no managing of the infrastructure underneath it. The idea is that the provider manages all of that for you. So in essence, function as a service is merely a subset of what serverless is. And this is quickly changing. As function as a service gains in adoption, there's a lot of new categories of services that are trying to fill the needs of serverless developers. So recently, for example, AWS released a serverless version of their Aurora database. Now, Aurora is an SQL-compatible database. And classically, you'd go to AWS, you would start up an Aurora instance, and you would use it as a database. Now, with Aurora Serverless, you don't need to do that anymore. You don't have to pay for that instance and keep it running. Simply make requests to Aurora Serverless. You pay only for the requests that you make. And on top of that, if your traffic is going up, AWS will automatically pull up resources to make sure that traffic is covered. So we'll scale your database. And there are more services there are more services getting created all the time, like AppSync and SignalR service, which are replacing technologies which were usually tied to server instances and turning them into serverless services, which are automatically scalable by design, where you pay for the actual usage. So let's quickly go through the pricing. Now, it's a little funny discussing prices at the Swift conference. This is an important part. Should I switch microphones?
It's this one. Yeah, thanks.
One, two. Okay, great. Working mic, always good.
It's the last microphone.
I'll try not to draw. Okay. Pricing is pretty important for serverless because traditionally when you use cloud, you pay for a specific time period, for example, a month or an hour, and you pay for a portion of hardware that you're using. So in essence, what you pay for is provision capacity. If your application needs to be available 24/7, then for 30 days a month, you'll have to pay for that provision capacity, even if no one is actually using your service. Serverless turns it upside down. So what you're actually paying for with serverless, you usually pay for the number of requests that you make and the time that it takes your code to execute. So what it means that while your application is available 24/7, if there's no utilization, if users are not making any requests, you're not actually paying anything. If you look at pricing across the board, it's fairly comparable for the large providers. So as I mentioned, you tend to pay for requests, for example, 15 cents per million requests to your service, and you pay for something called gigabyte second. What it is basically a unit of time combined with the memory that you use. So for example, if your function requires 1 gigabyte of memory and it takes 1 second to execute, that's 1 gigabyte of second that you used. Now, if you don't need that much memory to execute your function, let's say only half a gigabyte of memory, then if your function runs for a second, you only used half a gigabyte second. So, unfortunately, most of these providers provide a really generous free tier. So it's really easy to get started and test serverless as much as you want, and you might end up not paying at all. Now, the gigabyte second pricing is a little funky. It's kind of hard to understand the $0.000 dollars. So let's look at some specific example. On IBM Cloud, if you look at the pricing example, you can execute a function 5 million times, with each execution being around half a second long, and taking 128 megabytes of memory. This actually won't cost you anything, because it fits right in the free tier. Now, if we increase the memory to about a quarter of a gigabyte, and also execute our function 5 million times, about half a second long, then it's about $4. Now, if you compare this to the traditional model, where you would need to run a server for the whole month, you want to make sure it's got about 2 gigabytes or 4 gigabytes of memory. This is 10 or 20-fold saving, depending on your configuration. Now, because we're using Swift, things are not as simple as they are for everyone. Out of the big providers, AWS, Azure, Google currently don't have official Swift support yet. However, IBM Cloud, as Thomas pointed out last year, has with their OpenWhisk platform. Additionally, there's a lot of movement on the market with new providers like Swift Engine.io actually working on Swift-specific solutions to allow running your Swift code in a serverless manner. And as IBM Cloud does have Swift support, I'd like to quickly show you an example of how serverless FaaS works with Swift. So, quick demo time. So this works. Ooh. The one day you don't have a microphone. All right, I'm gonna go to, can everyone see? I need to make it a bit bigger. Right. This is the IBM Bluemix console. So to get started, I go into Functions on the IBM Cloud. And to create our functions on IBM Cloud, I go into Actions. Actions represent our functions. So let's create a new action. It's called the Swift test. And we can pick our runtime. It's a little tiny, but as you can see, IBM has Node, Python, Swift 4, Swift 3, if you need Swift 3, and PHP as well. Obviously, we're interested in Swift 4. Now, when we create our action, we actually have a little online editor, which allows us to edit our code through Safari. The main function is basically defined here. It's a main func, and it has an input parameter and a completion block. If we want, we can map the input parameter into a struct and process it here. And once we're ready, we simply return the result. So this is a simple sort of hello parameter type of program. Now, because we're in Germany, let's mix it up a bit. Did I spell it right? 2 L's. All right. And let's save. Now, once it's saved, we simply invoke. And side by side, we have our function editor and the output. Now, because our function takes a parameter, let's give it name. And then let's do Swift conf. One hand typing, mastering it here. And invoke. And there we go. We can see that the result object is willkommen SwiftConf. So that's how quickly you can get a function running. If we look at other parameters of our action, you can change the runtime if you want. You can set a maximum timeout just to make sure the function doesn't go on for ages. And you can set the memory limit. If you don't need as much, you can turn it down. That means your bill will be smaller. If you need a little bit more, you can turn it up. On IBM Cloud, every function can actually be exposed as an endpoint. But if we want to publish our action as a public API, simply go into the API section of IBM Cloud Functions, and we're going to create a very simple API. So let's click Create API. We'll need a name for it, Swift API. You can configure additional security. We're going to leave this for now, so it's going to be a public API by default. Let's give it a little bit of time. And there we go. Oh, I forgot an important thing. We have our API, but we haven't connected our action. So we'll create an HTTP operation. Let's just do path test. It's going to be an HTTP GET method, and it's going to run our Swift test. Let's just save that. Our API is updated. Now, this is our endpoint for the API. And it's going to add our path test. And there we go. Now, this is a public endpoint, so I don't need any authentication here. And that's what it takes to get a simple public endpoint deployed on IBM Cloud. Now, because you're developers, you're probably pretty familiar with the command line. Now, because Thomas covered it last year, I recommend checking out that. He shows pretty well how to use the OpenWhisk command line tools. I'd like to move in instead a little deeper into FaaS. So what I showed you now is a simple function that's triggered through the API gateway, and also triggered through the console, of course. what makes FaaS pretty cool is how well it integrates with other parts of your cloud. So you can trigger your functions through other services like simple data queues on your cloud, or other cloud services like storage. So for example, if you're uploading an image to a storage service like S3, you can actually invoke a function every time that happens. So then you can process stuff like images automatically without building additional HTTP services for uploading images. So it's pretty convenient. And it gets pretty powerful. If you connect it to something like database streams, then for every write, you can use your function to then replicate that data somewhere else, or for example, send a push notification to users if their user record changes. Besides that, you can obviously trigger a function based on the schedule if you need something to run every hour or every day. Now, let's take a look at HTTP and how running serverless differs from the traditional model. Traditionally, if you, for example, have a Vapor or Kitura server, you'd probably have a server process which has a socket, some middleware, and some routing that takes the HTTP request, turns into a request object, and passes it to the correct request handler. Now, that request handler takes the request object, processes the request, and uses the response object to send back a reply. Now, on FaaS, it's a little different. Generally, if you're building an HTTP service, you would use something like the API gateway, which receives your request. It's responsible for transforming that request and passes serialized information into your handler. Now, the function process can be pretty simple, as we saw. It could just be a simple main function. Is that outside?
Yeah, it's outside.
Okay. I thought someone has a very annoying ringtone. I was like, seriously? Anyway.
It's not you.
Wait, did I turn off my phone? Oh, shit.
It's not here for you.
Yeah, I was going to hide. Right. As we saw, the request handler on FaaS can be pretty simple, a simple main function that returns the object back. If you want, you could take some of the middleware and the routing and put it in your function process. But this is a slightly longer discussion. One of the consequences of this model is that the server process generally takes care of multiple requests. And we don't spawn additional server processes unless, for example, we need our application to scale further. Whereas the function process, by default, processes only one request at the same time. So if you're having parallel processes, then the API gateway takes care of your requests and then spawns a function process for every single that request. Now, if you're getting a little too much traffic from the API gateway, that'll be managed by your cloud vendor. It'll wait for the functions to finish and then execute additional ones. This is also pretty convenient because the resources for each request are very predictable. If your server process typically suddenly gets a burst of requests, then there's only the amount of memory that you have for that server process on that machine to use. Whereas when using FaaS, you have guaranteed memory and computing power for every request. Now that you show you that model, I'd like to do the second demo. So I showed you how to how the traditional model looks like. So what if we have the same application code in our traditional server as we have with our FaaS? And with an additional truist, I'd like to use AWS Lambda, which doesn't actually have a native Swift runtime baked in. So for this demo, I've set up a Git repository that you can check out later at home, which you can clone. And it contains a simple Swift Kitura application, as well as a Lambda service. So I'm going to open Xcode, our favorite tool, and bring up the code. So just a quick note, when you clone this repo, just use the generate Xcode script to generate an Xcode project, if you'd like to use Xcode. So I have some shared game code, which contains a simple game class, which then generates a game character and randomizes properties for the generated player character. It simply randomizes some basic data like intelligence, strength, dexterity. And let's look at our server. This is a super simple Kitura server. It has a player root and initializes our game object and then sends the player object, which is encodable. So if I choose the server from the targets, a quick run. So let it do its magic. And it'll be running locally. Let's make it a bit bigger. And there we go. Simple JSON response from our localhost server. Now, if we reload it, we'll get new values for our player. And we can even pass a query parameter. So let's give our name Swifty, and that'll be accepted by the server. And in Kitura, the way you do it, you exit the request object and look for the query parameters. So that might be pretty familiar to you, especially if you tried server-side Swift already. Now, how do you do the same with Lambda? So as you've seen, the function process under FaaS, it's going to be very simple. All of that routing stuff and middleware will actually be handled by the API gateway. So all we need to do is focus on our application logic. So the Lambda Swift file is basically a single process program that will invoke our shared code. So create the game, it'll generate the player, and there's a couple extra things happening here. So the way this is set up, our function will receive the event information. What I've done here is I mapped the event information I get from the API gateway into some parameters that we'll find useful. For example, the query string parameters. So the event information will come from the standard input. I'm going to decode that into an event object. Then I'm going to extract the name from the query parameters. And then finally, once my shared code is executed and I receive my player object, I need to first serialize that back into JSON. And because I'll be using AWS Lambda, I need to create a very specific response object. So I'll need to provide the HTTP status code, the headers, like the content type. So because it's going to be JSON, it's application JSON, and then pass the serialized player as body. Now, I can execute it locally, but let's see what it takes to do this in Lambda. So this is the AWS console. Now, first thing, I'm going to go into Lambda and create a new function. Let's call it Swift test. Now, sadly, we don't have the Swift runtime here, but that's OK. Let's do Node right now. And the execution role basically defines the permissions that the function will have. Because we're not calling any AWS services, I'm just going to use the basic execution role, which doesn't actually have many permissions. And just in case, I'm going to increase the memory a little bit and give it a 30-second timeout. You never know. Sacrifice the demo gods. Right. So right now, our function is empty. So we need to upload the code for it first. Now, I have Ubuntu running on Amazon. If you want, you can use Docker as well. So perform this on Docker or from virtual instance Ubuntu running on your local machine. One of the reasons why I like this, if the Wi-Fi is sticky here, this is all happening on AWS. So it's a bit of a practical measure that AWS will be talking to another AWS service. Here's my repo. And I added a little convenient script to deploy your Lambda here. So what's going to happen is I'm simply going to Swift build my project, and I'm going to zip up all the libraries necessary to execute my build results. As I mentioned, AWS doesn't have any Swift runtimes, so we have to ship it with our applications. As iOS Swift developers, you'll be very familiar with that process. And then finally, I have a little Node.js shim that will then call that executable. And once I have all of this, I simply zip up all of that code, and I can use the AWS Command-Line Interface to upload it to my function. Now, if you don't want to use the AWS command line, you can obviously do it manually on the panel as well. Now what's happening? I'm zipping up all the libraries. And finally, this is the response from the command line interface that my zip file was loaded. So now I should be able to go back to the console, configure a simple test event, and run. And there we go. You can see that the response that I created in the Lambda Swift file, including the result of the game object, are visible in the log. Now, again, having a function that just runs from the console isn't particularly useful. So let's see how that will work in the API gateway. So I have an empty API here, and I'm simply going to create a resource called player. And for that resource, I'm going to add an HTTP method. So similarly to what I've done on the IBM Cloud. And you can see that the API gateway isn't necessarily just for executing Lambda functions. So if you're not ready to use Lambda in some cases, you can simply forward it to an HTTP server. And whenever you're ready, just switch that API definition to fire a Lambda function instead. And I'm going to use the Lambda proxy information to get as much information about the event as possible. Now, I'll need to select my Lambda function. And it should be all set up. Now, there's a test button here to just make sure the API gateway can invoke this. And here we go. This is what our request is going to be. So I'm confident that this is going to run. So I simply deploy the changes into dev. And here's my endpoint. So I'm just going to open in a new tab. And I'm going to call our player resource. And there it is. Our Swift code is now running on AWS and invoked through the API gateway. Now, you might notice the little domain here. It doesn't look particularly pretty. What if we want to use a custom domain? Now, with serverless, this is actually pretty simple. So I've already configured a little custom domain here using my domain. And I've added a certificate from the certificate manager on AWS. I would happily do a demo here, but because DNS works the way it works, it might have taken a little longer. Now, all I need to do is simply map my test API to this custom domain, and hopefully this should work. And there we go. It's the same service, but it's now mapped onto a custom domain, so it looks fine and proper. And additionally, because I'm using AWS's ACM, it'll set up a certificate for me, and it will rotate it for me, so I never have to worry about SSL on my server again. So that's it. We saw the game code running Kitura in a traditional way, and just the game code distilled right into the function process on FaaS. And this beautiful pug. Okay. Obviously, there's no silver bullets in technology, as we all know. But there's a few great pros that I really love about serverless. Scalability is one. AWS Lambda, similarly to other providers, actually allows you to have about 1,000 executions in parallel of that function. Now, considering that you can unpap the memory to, I don't know what the current limit is. Shall we check it out? At least 2 gigabytes, but it might be even more nowadays. Let's crank it up. 3 gigs for a single function. I think that should be enough for everyone. That's pretty good scalability because it'll run this on demand. The other thing is stability. Now, if you remember from the graph with parallel requests, if a function handler somehow crashes the process, it only means that just that request fails. Your server is never going to crash because of one request doing something really stupid. So by design, it's pretty stable. The other thing is infrastructure security. If you guys remember Heartbleed, the SSL bug, it was it was pretty serious. And I'm pretty sure it took some of the smaller teams or indie developers a little while to patch all of their servers. And if you're using serverless, all of that is left to vendors like Amazon and Azure, which I'm pretty sure are going to be a little faster than me in updating these things. Now, some people say that security is a little more complicated with serverless, particularly because if someone hacks Amazon, then obviously you have a problem as well. So there's a single point of failure. But from a practical perspective, there's a lot of sort of convenient things here. And infrastructure security can get really tricky. And especially if you're a developer, you simply do not want to worry about this because you have other Swifty things on your mind. So the cost effectiveness is pretty awesome as well. Because you never know how busy your service is going to be, you're never going to risk spending a lot of money on making sure that you'll be able to scale to your popularity. So serverless will make sure that you're not a victim of your own success if your service suddenly becomes really busy. Now, I showed you the custom domains. The HTTPS inset rotation is one of my favorite features. The other thing, zero downtime updates. In the traditional model, I'm sure some of you simply just restarted the server process, but if you actually have something working in the wild and you have people actively doing requests, you might have to do something more complex, like redirecting traffic to a new server instance, server process, etc. Updates on FaaS are as simple as just updating a new version of your function. And from that point on, it will simply execute the newer version of your function, and there's nothing to worry about. And finally, I believe serverless encourages modularity because it's so simple to create additional functions and move around routes to either a different function or even an actual HTTP server. It has never been so easy to create microservices on the cloud. If you ever tried doing microservices the traditional way, you know that the operational complexity there is pretty huge. Now, it wouldn't be fair if I didn't mention some of the cons. So long-running processes is not really a thing that you'd want to do on FaaS. Now, the silver lining is if you want to do something like listening to the HTTP stream of events, perhaps you should be using webhooks. Or if you want to host a WebSocket server, perhaps you should be using a serverless service for that, which handles abstracts the real-time communications for you. But obviously, this is up to you. Now, at the moment, most of the serverless solutions will have a fair amount of proprietary elements. So you probably even saw now, the IBM console doesn't exactly look like Amazon. And if you look at Thomas's talk, the IBM Whisk command-line interface is not going to work like the AWS command-line interface. So there's a lot of differences here. And it's very hard to jump platforms. Now, if you use tools like the serverless framework, that should make it a little simpler. But these things just don't go away. It only gets a little bit better. So hopefully, this is something that will get better in the future. Now, the debugging is also a little harder. If you imagine on the server, something doesn't go well, you typically go into the server, maybe you connect through SSH. On serverless, well, you simply don't have that access. So it gets a little more tricky. The other thing that's pretty unique to serverless is cold starts. And it's the period when a request is going to your serverless function, but because that function hasn't ran in a while, AWS or Azure has to first download that function quickly and then execute it. And that's what I call a cold start. Now, once that's downloaded, the additional requests tend to be pretty quick. But it's something to be aware about, because I've already had some experience with customers that were wondering, why do I go to this service and the first time I load it, it takes 3 seconds? So learning how to mitigate that is pretty important. The other con, and personally, I like to make sure that most of my services are stateless anyway, is that a serverless function has to be stateless. So there's no ephemeral memory in the server process that you can access and use between requests. Practically every request is treated like a new process started from the beginning. So it is a design challenge to make sure that every request can be stateless. And there's a few things that, due to the design of serverless and its scalability, will have an impact on your database connection limits. So you have to make sure you properly benchmark that and make sure the connection limits are high enough. Preferably, if you can, use a serverless database. If you're building serverless, you might not want to, but I'm just warning you about that. And finally, thanks to the fact that serverless scales pretty well, the denial of services have become denial of wallet attacks. So your service is going to keep running if someone's going to keep hammering it. So first, make sure that if you don't need as much capacity as serverless is capable of, simply turn down the limits on the execution counts. And set up alarm on your billing so you can react in time. Now, there's a few interesting stories around the internet of people sort of experiencing these attacks. So definitely do some Googling. Now, if you simply can't go serverless because of these cons, there's always containers. And to me as a developer, I still found containers pretty complicated because they were previously fairly hard to deploy as well. With managed options like Fargate, Cloud Foundry, and Azure Kubernetes, this is much easier. So it's pretty great. But as much as it is serverless that these providers will manage the deployment of these containers for you, you still have this pricing problem where you're actually paying for the provisioned capacity of your container running. So it's pricing-wise, it actually comes out expensive than just having an EC2 instance. So finally, I think like this might seem a little outrageous if you're used to the traditional server model. But I do agree with Adrian Cockcroft, who's the VP of Cloud Strategy at AWS, that in the modern world, you should actually try to build serverless first. Because of all the performance and productivity feature it has, there's just it's just too bad to miss. And only if you need it, you should move to containers. And the good thing is, if your app is designed to run in a serverless manner, moving to containers is actually pretty simple, because all you need to do is change the way it's being executed. So I hope you enjoyed this. And personally, I enjoy being able to sleep at night and not worry that my server is not crashing, because there's no servers to crash. So thank you.
Microphone working again? It is for now. So keep
We
this
can switch if you want.
You have a question?
So I think I missed the part where you have your VM running, then you're attaching it to the Lambda, or what happened there? Because then my question would be, how do you ensure the up and down scalability, which is basically there at function level?
Were you wondering about the deployment process?
Yeah.
Right. So what is happening here is all of this code could easily run on your Mac. What it happens is, because AWS Lambda is a Linux environment, it's not Ubuntu, in case you're wondering, it's the Amazon Linux. You still need to compile it on Linux. So I cannot create the function zip file on my Mac unless I would somehow cross-compile. So this example is based on a pretty good example, and there's a link right in the README. It's so hard to see this resolution. There we go. There's a link here to a similar example of an Alexa scale. So here, if you want, you can actually just do this on Docker. Like all I need to do is somehow do Swift build in a Linux environment, so I end up with a Linux binary. Now, once that's done, I simply zip all the results up, and I submit it to AWS Lambda. And AWS will keep this code for whenever someone wants to run my function, it will download that code on its platform and run it for me. So there's, I can then shut down my MacBook, shut down the Ubuntu. That code is safely in AWS Lambda forever, and it will be ready to execute whenever someone wants to use my service. Does that explain it?
Yeah, definitely. Thank you.
Thanks.
Yeah. I'm throwing the microphone.
Hi. So let's say you have like some medium-sized web app with 20 endpoints or so and a lot of shared code logic. How would you structure and deploy a project like that without running into a configuration hell?
So, well, you have 20 endpoints or 20 routes. Oh, so well, let's see at the gateway, right? So this is my API. So right now, I just basically have one resource, one method. Are you interested in what happens if I add, for example, a new resource?
Yeah, so as far as I understand, like every resource has its own main entry point in the code, right? So you would like have 20 different main functions that all need to be deployed separately.
Okay. Yeah, so that's a valid concern. So what I could do is I simply create another resource, point it at the same function, right? Boom, that's another resource added. Obviously, the function needs to know what invoked it. So one of the things you can do, and I've added example in the GitHub. I kind of anticipated that this might come up. Where's this? Okay. This is the sample Lambda proxy object. So in the event, you'll actually know which resource was called. And you can actually see in the Xcode example that I mapped it onto the API gateway event. So simply check the resource string. If you're reusing the same function for multiple resources, where it was called from. And that way you can adjust your response in the main code to from where you called it. So if you're looking for a player, you're calling the same function, it will generate a player. If you're looking for a level, then just do a simple if statement. So if, or switch statement, event, resource. You can check these things, right? Now, basically what you're getting into is the architectural dilemma of how much I put into a single function versus how much I split into multiple functions for each resource. And that is up to you, basically. So we have the flexibility of building a whole web service into a single function. You can also use the proxy resources. So if I add proxy resource, it's quite interesting. Anything under the proxy path will get caught and pushed into your function. So you can treat the resource as a parameter itself and process that. You could create a whole thing using a single function, but that obviously comes with some consequences because some resources may be heavier, so you might want to provision more memory for it. So you'll probably want to use a different function with different configuration. Does that answer you?
Kind of.
I'm happy to talk to you later as well.
Hi. I'm not a Swift dev by day, so this may be a bit rich coming from me, but having like lots of main functions running around and doing basically only string juggling for input and output feels decidedly unswifty for me.
Okay, well, so it like how much abstraction you want and how much you want to transform the event object into something that's more programmatic is up to you. And you're absolutely right. So one of the things, I hope this is not going to be too confusing, is that if you wanted, you could actually put this router into a Lambda function and then turn that event object into a mock request object and pass it to Kitura. And just make sure you're not spawning a server port, but you just process that request. Like, in a way you would test Kitura, right, with a single mock object. Personally, I try not to do that because that's just additional stuff that I have to load. But it's a good point, and when you're probably starting out, you'll be happy with working with strings. Once your application gets more complex, I don't have an answer for you right now what's the best route, because I'm still exploring this, basically. But it's up to you, as creative you are, how to turn that event information into something that's programmatically more meaningful.
We have a question from the chat, actually. Wrong chat. I was looking at another chat.
Your iPhone is really small and
Yeah.
fits
Well,
on your wrist.
it's the only iPhone which you can actually hold in your hand in the meantime. So Pavel is actually asking, could he illustrate his experience with a bit more description of concrete services he's deployed using Serverless, FaaS? My imagination is failing me.
Can you repeat that question?
Oh, come on. You're gonna have me scroll again. It's like, yeah, exactly. It's like you when you were scrolling with like, all right, so let's try again. Oh, come on, Siri.
Okay, I think
Siri wanted to speak to me.
Okay,
Could he illustrate his experience with a bit more description of concrete? This is an amazing photo, by the way. The other guy's scrolling on my watch. So can you illustrate
yeah.
a real case, real life case?
I mean, my approach has basically been making sure that, first of all, I like to deploy locally, like first. It's just easier to build. We don't want to be pushing things into Lambda, so all the time. And one of the most convenient ways of doing it is just building Kitura apps, right? So whatever you would normally build for Kitura, you should do that, but just make sure that most of the requests can be run in a stateless manner. And then if you're ready to go to serverless, and your code is well abstracted. So most of your handler will just call a large chunk of your application code. It really doesn't matter if you're building a Kitura service and a serverless service. Now, there are a lot of details along the way, like we discussed. How do you split the functions? Whether it's in one big function or multiple functions. That is just a deployment design issue that for you to decide. So, I mean, just look at your Kitura service and see how the routes are structured and figure out, would it be the end of the world if some of these routes ran in a single executing functions? Anyway.
So Pavel's question was actually going a little bit in the direction of a question that I would have for you, which would be like, if there are out there real use cases of this technology right now.
I mean, I've been experimenting myself a little bit. It's new stuff. So most of my production stuff runs traditionally, but we have some internal services now that customers are testing that are running this. I haven't had any issues. So again, if you can design it and run it, if I've seen a lot of like Medium articles, people describing their experiences building services. So like so far, so good. It's just a deployment way of deploying your code.
And to conclude, before I give you the last question, so it's not ready to conclude, Dan. You broke my workflow. Now you even broke my mind. Forgot what I was going to say. You start.
Yeah, I was wondering. I was wondering if you can circumvent the issue of cold starts by just hitting the endpoint with a cron job every hour or something.
The short answer, yes. The longer answer is that I've mentioned parallel requests, and one thing to remember is that for serial requests, generally Lambda Azure will be smart enough to reuse that process and reuse the downloaded code. For parallel requests, it will have to cold start it for every request. So you'll kind of have to anticipate what traffic income you're going to have. If you need 5 parallel requests to always execute at optimal performance, you will actually need to hit your service 5 times simultaneously to make sure that there have been 5 cold starts and then 5 warm functions on that platform. So that's the only thing to remember. But your approach is correct. And then for about, I think on Lambda, it's about 20 minutes, that function will stay warm.
I remember what I wanted to say is you spoke a lot about Kitura, which is awesome, but there's another awesome kid on the block, which is Vapor. So check out like the last iOS Dev UK, for example, they have a talk about Vapor. I think last year we spoke about Vapor here. So this is also an interesting technology. Yeah, all right, so let's get Mateusz a round of applause.
Thank you.